Hello, welcome to Backer Breaks It Down. In today's episode, we are going to look at some applications involving right triangles. We're going to create equations using our right triangle trig ratios, sine, cosine, and tangent. And many of our problems are going to involve angles of elevation or angles of depression. So take a look at this diagram here. Notice in the diagram you have the girl observer that's on the ground, and then you have the hang glider. Okay, now the girl who's standing on the ground, when she goes, like if she were looking like straight ahead, that's her horizontal line of sight. And when she looks up at the hang glider, that angle that went from her horizontal line of sight to the hang glider, that's the angle of elevation. Now, the person in the hang glider, if they're looking straight ahead and then they look down at the girl, that angle at which they look down, that's called their angle of depression. Now, you'll notice in this diagram that the angle of elevation and the angle of depression are both 38 degrees. And the reason why this is because those two angles are alternate interior angles. You may recall from geometry, if you have parallel lines cut by a transversal, these angles here are alternate interior and they're congruent. So this is like a good thing to know, that these angles are congruent, because like if you were to draw a right triangle, like notice that like the angle of depression is not in my right triangle, but since I know that the angle of depression, it would be congruent to the angle of elevation, like I can work with that because of that congruence. So here's just another diagram showing you maybe more clearly the angle of elevation versus the angle of depression, okay? And so a diagram is really helpful when you're working with these word problems. So if you don't have a diagram, I would totally just draw one. You could keep it simple, just make yourself like a right triangle and just start labeling things, all right? So let's take a look at some examples. So a plane rises from takeoff and flies at an angle of 10 degrees with the horizontal runway. When it has gained 500 feet, find the distance the plane has flown. So they did give us a nice diagram here, so we don't have to go creating our own. So just like before, when you're working with these problems, ask yourself, what do I know? What do I need to know? How can I find it? And so in this problem, since we know that angle A is 10 degrees, we could be like, well, what else do I know? Well, I know the side opposite angle A is 500. What do I want to know? Well, I want to know this hypotenuse, because the hypotenuse is representing the distance the plane has flown. So what do I know? I know the opposite. What do I need to know? It's the hypotenuse. How can I find it? Well, sine is the ratio that relates the opposite and the hypotenuse. So that's what I'm going to use. So I'm going to be like sine of my angle, which is 10 degrees, is equal to the opposite, which is 500, over the hypotenuse, which is x. Okay, so that's my initial equation. Now I just have to solve it. So I can cross multiply. So I can go like sine of 10 degrees times x. So that is x times sine of 10 degrees equals 500. And since x isn't entirely all by itself yet, I need to do one more step. I need to do division, because what I have is x times sine of 10 degrees. So if I go and I divide both sides by sine of 10 degrees, I will get x all by itself. And once x is all by itself, then I'm ready to calculate. So on my calculator, I'll type in 500 divided by sine of 10 degrees, and I get 2,879.4 feet. And so that's the distance the plane has traveled. Make sure your calculator is in degree mode. So if you did not get that as your answer, if you got something way different, press mode. I bet you're in radians. So make sure that that degrees is highlighted so you get the right answers here, okay? So let's try one more. It says a sledding run is 300 yards long with a vertical drop of 27.6 yards. So draw a sketch that represents the situation. So my sketch, I got it all ready for us, okay? So the sledding run is 300 yards long. So we're talking about the actual part of this triangle that like you're sledding down. And so that would be this part right here. And then it says the vertical drop is 27.6 yards. Okay. We want to find the angle of depression. So that would be this angle right here, which isn't part of our triangle. But remember, the angle of depression is congruent to the angle of elevation. So this angle here has the same measurement. So I can find that angle. And by finding that angle, I'm also finding the angle of depression. So if that's what I want to know, what do I know? Well, I know the side opposite that angle is 27.6. And I also know the hypotenuse in this triangle. So how can I find my angle? Yeah, I can use sine because sine is the opposite over the hypotenuse. Now, since I want to know the angle, I have to calculate the inverse sine of the opposite, 27.6, divided by the hypotenuse. And so I need to see that inverse sine notation on my calculator. So remember, like I often say, wait a second, I don't know the angle measure, because that's how I remind myself I need to go second sine, and then I can type in the ratio. Okay, and so my calculator tells me that it's 5.3 degrees. So these are two very basic applications involving angles of elevation and depression. We're still kind of like utilizing the same mindset that we were utilizing before when we were finding missing sides and angles in triangles. We're like, what do I know? What do I need to know? And how can I find it? Okay. And that's how Becker breaks it down. Bye.